All right, so the next part of the semester project is going to deal with generating a horizontal alignment for your roadway. So you already have your center line. Everybody has their center lines, or at least they should. Okay. We all remember from earlier in the semester that an alignment is just sort of referencing the roadway from its beginning to end. Okay, and you put horizontal stationing along it. The beginning of it, you'll make 0 + 0, 0. And then every 100 feet, it'll be 1 + 0, 0, 2 + 0, 0. And it's just a way of referencing where you are horizontally along the road. Okay, with respect to either the beginning or some other point on the road, like the beginning of a curve, the end of a curve, something like that. So that's the horizontal component, is the alignment. The vertical component is called a profile. Okay. Picture taking the world's biggest saw and running it down the center line of your roadway and flipping it so that you're looking at the side of the road. Okay. That's what a profile does. Okay. I'm going to. So what we're going to be talking about is chapter 25. Okay. Vertical curves. Because you're going to need to generate vertical curves along the road in your subdivision. And we'll talk about sort of the logic and reason why here in a second. Right. So if you took that saw and cut it through where your roadway goes through, right, the existing ground kind of undulates, right? It goes up and down. And we kind of took a look at some of the contours and we kind of identified where the low spot was, and that's kind of where I hope you put your detention pond. Hopefully you set aside some area for the recreation, like I said, and the other. But most likely, the detention pond would kind of be somewhere in this area, right? But talk to me a little bit about what you see. Like, if you just got in your car and you drove across the field, anybody ever go to a rodeo where they parked out in the field? Or to a concert where you parked out in the field? Yeah. So the road's not paved, but you just kind of go up and down. The contours of the land that you had in your subdivision kind of follow that darker ground profile, right? Then what you're going to do is you're going to come in and you're going to design your roadway. Well, what do you notice about the finished grade where it's a black line, a tangent 1, tangent 2? What do you notice about that? What did they obviously try and do with their design? Make it straight, right? Make it as straight as possible. They did that. But what else did they obviously try and do? Did they just cut a straight line through here? They kind of follow the contours, so what they have to do. Right, they kind of tried to follow it as best as they could. And that's generally what you try and do, is you try and follow the existing ground as much as possible. Because if I just cut a straight line through, what's going to happen? What's going to be the consequence of that? It's going to be easier to build, yeah. But what are you doing more of? You're making the contractor do more earth, right? You're moving more ground from one place to another. So everybody seeing here, the black line is where the finished road's going to be. And this bluish gray line is the existing. Right in here They're going to be filling in, they're going to be cutting, they're going to be filling, they're going to be cutting. Everybody see that? But they're minimizing the amounts that they're doing. There may be other cases where you see where you have a spot where you need to fill that area in. So then you want to have another area of cut. Okay. Anybody drive down a highway that was cut into the side of a mountain, and it's fairly obvious. The mountain side is a cut, and the other side is a fill where there's a guide rail so you don't go off. Right? They kind of walk the road up the mountain gradually. That's where the finished grade profile and doing a profile of your roadway alignment is going to help. I'm going to show you how to do this in Civil 3D. But it's important to understand what's running in the background. What are the equations that the software is using? So this is all chapter 25. Okay. Why do you want to have a vertical curve where there's a grade grid?
Obviously, so you can drive over it.
Right. So essentially, if you have a high point like this, that you're not making a ramp, you're making a road. So let's talk a little bit about nomenclature first. Is a vertical curve actually a curve? No. Well, kind of. Is it a circular curve? No, it's a parabola. This first equation up here on the board, it's equation 25.2 in the textbook. I'm sorry, 25.1. This is 25.1. This is the general equation of a parabola. Right? All of this is in the textbook. Okay. All of these variables are shown in this picture. A is your starting reference. BXP is as you're working up that slope. B is the slope. Okay. The textbook goes through and derives additional equations in terms of what we would use as surveyors or civil engineers for a vertical curve. EVC is beginning a vertical curve. EVC is end vertical curve. PVI or V, that's the intersection of the two tangents. Right. Now, your grades, G1 and G2, those are always done as percent grade. Okay, so what I mean by that is slope is rise over run, right? Okay. So if you have 1 foot of elevation change over 100 foot of roadway, that's a relatively flat roadway, but it's a gradual slope going up or down. Right. Slopes are directionally sensitive. So G1 would be positive, G2 would be negative. Okay. But your slope, the one that I just said, 1%, that's 1 foot of vertical elevation change over 100 foot of run. So if you did that in your calculator, it would be 0.01, right? 0.01 as a percentage, you multiply it by 100, you get 1% grade. The equations in the textbook, G1 and G2, are such that it's the percent grade, it's 1. It's not 0.0. Okay. Follow? Okay. So the equation goes through and solves for this C, and then they plug C in and get to here. And then this G1, G2 over L, that is the rate of change of the vertical curve. And then they plug that back in to this equation to get to this. So your Y position, your vertical position, is your elevation at the beginning of a vertical curve. Plus, so working your way up, G1 times X, and then R12 X squared. That is calculating that right there. Okay. How do you calculate your X position? That's subtracting stations. So if you wanted to know what the elevation was of your PVI, right here, and I tell you that it's 1,000-foot vertical curve. The curves that we're going to deal with are equal tangent vertical curves. Yes.
For the last equation, is there a symbol missing, or is there two X terms in like the same part? It looks like there's two X's that like multiplied together. So is there like a plus or?
Well, this is X and this is X squared.
What is that plus?
Yeah.
Is it G1X plus
Oh,
R2, R2?
It's the same thing, two equations on that small.
So it's a,
yeah, so there's a plus.
Okay.
Kaylee, thank you. Thank you for catching that. Yes, there is a symbol. Sorry. Thank you both. Davis for explaining it to me so that I understood it, Kaylee for finding mistakes. So, everyone okay with the equations and this? We'll do a couple examples of this. I just wanted to get the equations out there first, so we can start talking about this. So in surveying, right, if you're given that your beginning of vertical curve is here, right, you can calculate 4370 to 4970. Everybody sees how this is a 600-foot vertical curve. The PI, it doesn't matter if this slope is different than this slope. This is going to be, the PVI is going to be halfway in between, no matter what. So if you add 300 feet to this, you're at 46 plus. Everyone sees that? And then what they're doing along here is they're saying that, okay, here's my starting station for the vertical curve. 844.48 is my elevation at this point vertically. Right? And all of these elevations are working along the vertical curve. So this elevation here is at this point, not the projection of the tangent. Right? That's the elevation of the PVI. So if you subtract, you take your calculator and do 853.48 minus 844.48 and divide that by the 300 feet, you should get 0.03. 0.03 as a percentage is 3%. I going too quick there? This is going to be on the final. There will be at least one vertical curve problem on the final. In practice, do you typically do vertical curve calculations manually? Typically, no. Typically, this is done in Civil 3D. You're confirming stuff, you're making sure that everything makes sense, but the calculations are done typically with the software. When I bring the screen up, there are two equations there that indicate the position of. So I'm going to stop sharing this temporarily. So if a vertical curve, there's two types. If I have a positive going in and a negative going out, a vertical curve going like this, this is called a crest vertical curve. If I do the opposite, if I have a negative grade coming in and a positive grade going out, anyone want to take a guess at what the super complicated definition of this type of vertical curve is? Sorry. Sag. Which one do you have to be most concerned about for drainage? Sag. Because wherever the low point is, you want to make darn good and sure you get some sort of drainage feature to collect that. Agreed? Otherwise, you're making a puddle. You have a pool, not a road. Not cool.
Still fun though.
It could be, under the right circumstances. Which one's more important for sight distance? What about at night? Okay, one thing at a time. I agree with you, crest is more important for sight distance. But there are two types of sight distance. Actually, I'm sorry, I apologize. There's three. There is stopping sight distance and passing sight distance. It's exactly what it sounds like. Passing sight distance is if you're approaching another car, that you're going past something. Stopping is if there is something on the road, an obstruction on the road. Typically, the worst spot is wherever that object would be hidden from your line of sight. So for stopping sight distance, the height of the object is basically like half a foot. You want it to be almost to the ground. Your object, your eye height, this isn't in the textbook. Your eye height is typically calculated at, what would you think? It's actually 3.5 feet. So, yep, bang on. Is that right for most vehicles today? Probably closer to 4 for most vehicles today because of SUVs and pickups are tend to be a bit more common. Passenger cars, you're closer to 3.5. But for the purpose of the calculations, like most DOTs use 3.5 feet. So you have passing sight distance and stopping sight distance. So for passing sight distance, you're assuming that the object is 3.5 feet high also, because you're passing each other. 3.5 feet. Stopping sight distance, the object height is half a foot. The reason I asked Chris about being at night is if this is my car, I'm going downhill. Which way are my headlights pointing? Headlights are typically aimed slightly down. So if I'm going in a sad condition vertical curve, and it's a pretty abrupt condition, I'm looking more at the roadway and not further out. Right? This is actually called headlight sight distance. And it's typically only for a sag vertical curve. The reason that's important is because it leads us to the high point and low point. So depending upon the grade going in and out, right, is going to dictate where this high point or low point would be. If I've got an equal grade going in and going out, and it's an equal tangent vertical curve, where is it going to be? Right in the middle, because it's the same going in as going out. If going in and going out are different, the high point can be one way or the other, or the low point can be slightly one way or the other. And you don't have to be thrown. Jeez. The way you calculate the horizontal position of a high point or a low point is with one of these two equations. If you're given the grades going in and out and you have the length for a curve, there it is. If you're just given one of the grades, but you know the rate of change, that's the other. So next class, we'll do maybe a couple examples of this. Right? But pretty basic, pretty basic algebra, nothing really too complicated. Just knowing where to plug the numbers in and what this is giving you. So if you wanted to know the low spot elevation wise, you would take that horizontal position and use that over here for your X. So the X can be anywhere along that curve if you want to copy. So let's talk about how the software does. But before I do that, I want to take one step back. It's easy to think that, okay, I've got a horizontal layout for my road, right? And I've got a beginning of curve and end of curve. Does your horizontal curve and vertical curve have to coincide at the same position? They're completely independent. Don't try and link a horizontal curve and a vertical. They're not related to one another at all. The vertical curve is just how you transition grades from one to another. Now, if I had a gradual change in grade, right? So let's say I had an existing road here, and I'm starting my subdivision off to the side here. Should I put a vertical curve in to begin my roadway? Or can I have, for lack of a better expression, a little bit of a kink there? What do we think? What about in a driveway? Is it okay to have some change in grade there? As long as it's not ridiculous, right? And especially if it's a stop condition. Like if you're stopping at an intersection, that can have a kink to it. The maximum, according to most DOTs, is an 8% change in grade. So if the road has like a 2% slope, the maximum you can go up is 6%, because that would be an 8% change. It's an algebraic difference. What about in my subdivision if I only have a slight change? Like if I just have a little kink, if it's less than 1%, the township isn't going to make you a vertical curve. So long as that difference in grade isn't greater than 1%, you can get away without one. Okay. So the last thing that you're going to have to do for the semester project with CAD and Civil 3D is in an alignment and a profile. Okay.
So that less than 1%, I'd assume that'd be over a distance, because then you could vary it like 1% a foot later, another percent.
Right. Right. I mean, it's typically your roadway design, you're running one tangent for several hundred feet.
Right.
So when we do construction layout, we lay out the roadway every 50 feet, except along a vertical curve, then we're laying it out every 25 feet. So in all practicality, is the blade of a bulldozer grading a curve, or is he doing what you're saying, going every 25 feet? And yeah, that's more what he's constructing than an actual sweep curve. But when you do your profile, we're going to exaggerate the horizontal and vertical scales so you can see the changes in grade. I'll talk a little bit about that. But your horizontal scale is going to be, say, 1 inch equals 50 feet. But your vertical scale isn't going to be 1 inch equals 50 feet. You exaggerate that so you can see the curve more clearly. Because if you looked at the plan and you saw the curve the way it's going to be in real life, it's going to look so gradual that you're not going to be able to pick up the detail. So there's always, in roadway design, there's always a difference between your horizontal scale and your vertical scale. And it's usually a 10 times exaggeration. So if your horizontal scale is 1 inch equals 50 feet, your vertical scale is 1 inch equals 5. If it's 20, it's 20 and 2, horizontal and vertical. 110, you get the idea. Right? Okay. Let's go back to Civil 3D. And I'm going to open my design. And we'll talk a little bit about creating an alignment and profile. So I have my roadway. Now my curve should have been done tangent, so that there should not be a kink in it. Okay, so I have a road here and I have a road down here. Well, I don't have this road tied in, so maybe I should do that quick. Okay, so I'm going to switch over and I'm going to make the road my current layer. Now I want the road to tie in perpendicular to the existing one, right? I don't want to have a funky angle on that intersection. I don't want to come in at an angle. Usually intersections you want to be 90 degrees. Okay. Don't forget, in the ordinance, there was a requirement for how far this tangent distance needed to be. Okay. So what I'm going to do, I'm going to use a 200-foot radius. So that's tied in. And then this road everybody sees, oh, I have this road generated and I have a road generated. The easiest thing is to have one continuous polyline for the whole thing. And you want to make sure your curve is tangent at the two ends. The easiest way to do that is with a fillet. You can do curve, tangent, tangent, like I showed before. Don't get overwhelmed with the different ways to do things. All right. In CAD, there's 3 or 4 different ways to do the same thing. Okay. If you can't figure out how to do it, just ask me. But I'm trying to show you multiple ways. So if you like fillet, use fillet. Okay. I want this to be a continuous polyline because it's going to make my life easier when I make the line. All right. So to make it a closed line, type PE, select one end of it, right? And then you've got different options. So I'm going to join this piece with that piece, with that piece. Now, if I select it, if I move this, everybody sees how it's one continuous segment. Step 1 is creating a horizontal line. That's where it's going to assign it station, right? Assign it references. What do we want to call our roadway? Somebody give me a road name. Come on, I know it's Wednesday and I know that's on. Pardee, there you go. Thank you. Okay. So to generate an alignment, right, you have alignment here, which you would need to go to home and select an alignment. The other way to get an alignment is, it's hard to see because the Zoom toolbar is above it. You see how there's an alignment pull down menu? Right. That pull down menu is if you bring in for some reason I don't see. Right. So if you don't have the alignment pull down menu, you can go here to alignment. And that's under home. So alignment, alignment creation tools, create alignment from objects, create alignment from corridor, best fit alignment. You've already created it. You have a polygon. So you're going to select create alignment from objects. The same command lives here also. Create alignment from polygon. Okay, it does the same thing. So from the pull down, I'm just going to hit create alignment from polyline. Okay. After you select the alignment and hit enter, everybody sees how I got this white arrow? That's indicating the direction that you want the computer to draw the alignment. So it's saying to you right now that I'm going to make this the beginning and this the end. The arrow is pointing the other way, that would be the beginning of that. Common practice is that you don't make your alignment begin and end at 0, because if you need to calculate back stationing for any reason, right, then you don't have to deal with negative numbers. Right? Could you make it 0? Of course you can. So if you wanted to flip the direction, look down here on the command line, you see where there's a little R, a blue R in front of reverse. If I type R, it would flip the direction of this and it would say that the beginning is at the other end. Typically alignments, when you do stuff for DOTs, alignments run south to north, west to east. We've all driven along interstates, right? Where's mile marker 0? At the southernmost end or at the westernmost end? And it advances west to east, south to north, right? Same thing with stations. It advances south to north or west to east for the predominant direction. So you see how this road kind of goes to the west and then it goes back to the east, but it's mainly going south to north. So I'm going to say that my beginning is down there. That makes sense? Okay. So once you have that down on the bottom, if you're happy with the direction, just hit enter a second time, and it's going to put you into this screen. Create alignment from objects. Yes, please. Alignment name. You can call it My Happy Roadway. We are going to go with Pearson's suggestion. Part E is 2 E's, right? Mm-hmm. The type of alignment. Typically, you don't change this, but there are options, right? You can do an offset, you can do a curb line, you can do a railroad. I don't know anybody designing railroads, but just leave it at center line. And here's where you would change your starting station. You could change it to something other than 0. For this assignment, you can leave it at 0. Like I said, for practical purposes, most of the time when I do it, I'll make it station 10 plus. It's a nice even station, but if the township comes back and says, we want you to extend that down to the creek on the other side of the road. So now instead of having to redo the station, I've got, 1,000 feet to play with. Okay. So for now, I'm just going to make it 0. The site. Sites are a way to keep things sorted out on a big scale project. For what you're doing, leave it at none. But when you get out into the real world, you could have different sites, like you could have phase 1, phase 2 of this subdivision. Okay. For the alignment style, you have design and existing. Is this an existing roadway? No, so we're going to leave it at design. Right? Labels. When you get to where you're going to work, they're most likely going to have their own set of labels. Okay. The one that I typically use is all labels. Right. Once you have the alignment generated, you can go in and change that. It's just a set. Okay. I'm just going to leave it to what it was set to. Okay. If these aren't in the drawing when you go to do it, then you need to insert that template drawing that I have. We started from scratch, and that is in. Everybody know what I mean by that? Just need to insert it as a block, and then those styles will appear. If you did your design correctly, you can click this add curves between tangents off because there are curves already there. Okay. That polyline is in there as a separate line. Down here on the bottom, if I click erase existing entities, it's going to erase the polyline. It's going to draw a center line, but it's no longer going to be a polyline. Right? For me, I'm going to turn that off. I want to leave my construction line there. You can choose to delete it. It's not a big deal, right? Watch what happens. Ta-da. Now, this is important, okay? Your X reference, right? If your drawing sheet was 50 still, but your drawing is still set to 20, you see how my labels are small? If I go down here and change this to 50, see what it did to the labels? So make sure you're working at the scale you want your sheet to be set up at. Otherwise, you're going to be like, my labels disappeared. That's why the labels disappeared, because your annotation scale is different than the drawings. Okay? That is how you create a horizontal alignment. So this is how you get the stationing for how everything is referenced. Okay? You have enough that you can go in and do the same thing for your roadway, so you're ready for the next step, which I'm going to show you all on Friday. Friday, you'll have everything you need to generate your alignments and profiles. And then Tuesday, if you get it done and you don't want it, like, good for you. Okay, Chris.
When you do the stationing for the open road,
Yeah.
would you start at 0 at that bottom?
That's a good question. I typically make it something different. So what I'm going to do quick is I already have the road designed, right? I'm going to an alignment, create alignment from object, enter. Yeah, I want it to run that way too. I'm going to call the road something else. But yeah, I can make this 500. Turn that off. Turn that off. Ta-da. Now I've got two. Typically, what you're going to do in practice is call out this intersection. You're going to call it out with both sets of stations. It's the station of this for this road and the station of this for the other. So intersections typically have 2 stations for both roads. Good question. Friday, I am also going to distribute paper copies of peer evaluations. In a perfect world,